Today, I want to talk about how Tesla is will become the only full stack AI company, or at least it'll be the first one to become a full stack AI company. By that I mean that they will make not just the large language models with XAI, but they make the data center, they will make the chips, not just the training chip, competing with NVIDIA's B200, B300 with Dojo 2 and 3, but also inference chips with AI 5 and then AI 6. So, and then they'll make the products, the main products that matter, humanoid bot, robotaxi. So we're going to talk about how they're going to make all these aspects of it, which is many, many things, which is difficult for other companies to compete with. And we have Randy Kirk with me here.
I was already agreeing with him before he introduced me. He's already
Yeah.
right. I mean, oh, look at that.
Yeah. So we have a little bit a deck here that will go over that. So some background as to where we are. Previously, for 50, 60 years, we've had Moore's Law, computers doubling every 2 years, compute power doubling every 2 years. For the last um, 15 years, AI has been increasing its compute by 4 to 7 times per year, which is a huge increase in speed. It's like um, over the course of 10 years, you go up a million times instead of 1,000 times. It's
Right.
like this huge increase. But um, XAI Grok 3, released in late February, was 15 times more powerful than Grok 2 was only 6 months before. Grok 2 was released 6 months before, and now we have this one. And Grok 3 uses compute that is about 10 times more than other competing models that were at the 30,000 GPU level, where they're at 100,000, but installed with the better, faster chips. So they've already gone to this next level of speed and development. So, but things are still progressing fast because at that call, they said that they had another 100,000 chips installed that they did in 90 days end to end. So this goes to building that AI data center faster and better than any other competitor, which is not just me saying that, but Jensen Huang, CEO of NVIDIA, said that they built it faster than anyone else, that they were superhuman in how fast they built it. And they are adding in more power. So they have, um, you know, to run the Grok 3 training, they had about 250 megawatts of power. And now they're adding in another 240 megawatts over only a few months that they got the permits to install more turbines. And now they bought B200 chips, which are um, 4 or 5 times better than the H100. Net is that within a few months, they'll have 12 times the compute power um, of the Grok 3 training. So if you go back 1 year to Grok 2, they will have 12 times 15. They'll have 180 times more compute, which is, again, far faster than the 4 times to 7 times pace. They're going at 180 times per year.
Okay, so I've been meaning to ask you,
Yeah.
who's in second right now in terms of compute, or do we even know? Have these other companies announced the total amount of their compute to like ChatGPT or Microsoft or anybody? Have they announced their numbers, or what do we know?
So what we know is that the there's a lot of compute from Microsoft and from Google and Meta. Facebook Meta has a lot more GPUs, but so they have 100,000, 200,000 GPUs. They have that number and even more. So they're buying a lot, but they do not have them in one data center, one building. They have multiple buildings for that. Um, the AI needs to have all shared memory. So the chips doing the processing and the memory beside them, it needs to look like one giant memory, right? And if it doesn't work as well. And so if I have it in a separate building, 30,000 here, 30,000 there, 10 buildings adding up to 300,000, yes, overall I have that much compute, but if each one's, it's like I take part of my brain and put some over here, some over there, some over there, it doesn't work as well.
Right.
Not as fatal,
Yeah, right, right,
for
right, right.
them, but it still doesn't work as well, right? So, or it's like, 10 people thinking about something versus one super brain, something like
Right.
that. So Google has a lot of chips. They have 3 million, but they're using their TPUs, which are not as powerful as the NVIDIA
GP.
GPUs. They're inferior. They're probably about like 300 um,
Oh,
300 gig of teraflops, something like that. So they're basically not dissimilar to the version 1 Dojo chip, which
okay.
is inferior to the H100.
Right.
So kind of like at the A100 level, something like that. Anyway, so they have, again, a lot of buildings, a lot of stuff. So no one else has it in one building.
Got it.
And when they do all their training at, OpenAI releasing their models, right? They haven't gone that far beyond GPT-4. They hit that 30,000 chip
Right.
wall
Right.
because they need to redo the communication in between them.
Right.
Um, Google has more chips talking to each other, but they're weaker chips, but
Uh,
they're designed differently so they can get more chips talking to each other,
and
right?
do these facilities at Google and Microsoft, are they dedicated to the LLM or are they doing other work?
They have many, many dedicated buildings, but they have other buildings like Amazon has other buildings for their cloud services.
Right.
So Microsoft has cloud services, but they have extra chips set aside only for their AI work.
Okay.
Yeah. But the main thing is the not being able to get the communication to have them all work
Right.
together.
Right.
Um, how much can you do the split up thing? Obviously, they'll have very smart people trying to figure out how to
Right.
reduce that penalty. But I think it's unavoidable that they would have certain issues with that.
Right.
So this showed how fast they caught up. So they went from 2023 to get to up to the GPT-4 level, which is where everyone kind of got stuck. A lot of
Right.
people got stuck at that
Right.
level. And then this is only Grok 2, and then Grok 3 is 15 times higher than that bar.
Right.
And then Grok 4 out in August will be 108 times bigger than that bar.
So
So
August.
yeah. Yeah, so basically, the acceleration that they will have and the lead that they will have before the others figure out how to solve these problems will be huge. They're throwing it into warp speed that the other guys have not caught up with. So over me projecting things out, you know, this year's special, they can go 108 times or 750 times,
Right. Right.
within 18 months. It'll slow down some because there's issues energy scaling and other stuff like that. But they could be in the a sustainable 50x per year range for a few years.
Hmm.
But it's irrelevant because if they get this huge burst for 3 years,
Yes.
there could be a competitive dominance that they can establish
Right.
before anyone else come together. And going to the full stack thing, they're going to be making Dojo 3 chips, which could be, or Dojo 2 chips at the end of this year, and then Dojo 3 chips next year, which could be competitive with NVIDIA.
Right.
And they are getting about 15 to 20% of all of NVIDIA's chips right
Hmm.
now.
Hmm.
So NVIDIA is going to make 4 million B200 and B300 this year. If um, XAI is going to have 800,000 of those all in the Colossus data center.
Yeah.
800,000 out of 4 million, that's 20%,
Right.
right? And if they start replacing those with Dojo 2 and Dojo 3 this year and next year,
Uh-huh.
if they have more than, um, I think, 200,000 equivalent of the, uh, yeah, of those chips,
Huh?
they would surpass AMD in terms of being second place for chip making.
I
Because
see. Okay.
AMD only has 5% of the market or something like that. They make 400,000, 500,000 chips. But if your chips aren't as good as NVIDIA's and
Yeah.
something like that, then but definitely if you get to 800,000 um, of your own Dojo 2 chips that you're buying for yourself, or Dojo 3 chips, then they could surpass AMD in terms of that.
Hmm.
That being said, Google makes their own TPU
Right.
chips,
Right.
right? So they're kind of also in the AMD range.
Hmm.
Uh, Amazon and Meta are also trying to get to that level. So passing AMD at that 5% level, it's a impressive accomplishment one way, but it's less impressive the other way. But in terms of the full stack, AMD, I think, worth $200 billion, $150 million.
No, but
So
it's
surpassing them is a non-trivial, like
right.
some of the parts company thing. Anyway, so Grok 4, 12 pounds of compute, Grok 3, which will be built at the end of this year, and
Uh-huh.
then training Q1, Q2, or like that, and then releasing Q2 or something like that, will be 50x, which the 12x and 50x, as much training in a month as you do in a year with the 12x, as much training as you do in a year in 1 week with the 50x. So that's kind of the scale of what we're talking
Yeah,
about.
and you misspoke there a minute ago. You said Grok 2, you meant Grok 5. So Grok 5,
Sorry,
one that would
yeah,
be
Grok 5, yes. Sorry. Yeah. I was thinking 50 times more than the computer Grok 2. And
yeah.
then I had the details of this, which we've gone over a few times, but I'm thinking that the Dojo 2, Dojo 3, Dojo 4 could start keeping pace with the NVIDIA chips. And then even if they don't displace them totally, um, being competitive would be a huge deal to because they'll have supply issues. They'll only be able to probably have 10 million, 8 million chips if everything goes perfectly in 2028. So that means if XAI and Tesla wanted 3 million or 4 million chips, then it's like, I want half of your supply.
Right.
And then it's like, if you were even allowed to do it, you have to start a bidding war. So they
Right.
need to make a lot of their own chips. This is the power thing that they're using to get these fast installations. Colossus, the Memphis data center area, has enough room for 3 million chips, but
For
they would
3
need
million.
to add, they
3
need
million?
to get, yeah,
That's
they
new
have enough
news. Okay.
servers, chips, worked out the space on that, they got 3 million. They would need to then add 2 more gigawatts of power. They need 3 gigawatts of power. But in terms of the same building, of course, you can always make more buildings. But again,
Right.
I want them all in one spot talking to each other thing
Right.
is why I want to pack them in to a data center.
But the interesting part about that is that the 1 million that we've been talking about for the last 3 or 4 months, there's plenty of room for the 1 million. And now
Yeah,
you're saying that even after that, a couple of years from now, they can move on to 2 million and then three.
right, right. There is a bunch of uh, challenging issues around making it talk together, cooling it.
Yeah, yeah,
There's it's like I can just put it onto a thing. They have to do a ton of work to
yeah,
figure this out.
yeah,
Um, I had projected also that we're going from $300 billion per year of overall spending on AI to 1 trillion. The people
yeah,
who say that's going to stop, I disagree.
right,
Um, and then show how this growth where how you put more money into it. Um, the AI improving, they got to share the lead, even though they had far fewer years to work on things. And then we'll be tracking how this only works if Grok 4 really blows the other
right,
models out of the water. I would
right,
expect it to be substantially better than
right.
anything else. Same thing for Grok 5.
So, and there's a second part to that. Of course, we're talking about the stack right now, but
Yeah.
the second part of that is, of course, the interface. And so,
Mhm.
like I've been playing around with the illustration stuff a lot,
Yeah.
and it's good,
Mhm.
but it needs some work.
And then other video picture editors are superior,
Yeah,
right?
yeah,
So, but getting that multimodal part, not
right,
just great text, but also great video and great images and great
right,
image editing
right,
is something that should be a part of the complete solution. Grok 4 video, I'd be, very disappointed if they weren't, leading
right,
whatever's happening there. And it would also show that there's some issue with um, how clever you program it versus anything else.
right,
Um,
right. Yeah,
here's something just about the falling prices that people made a big deal about DeepSeek, but that um, OpenAI, Anthropic, and others were dropping the price of the AI. That you're getting more value other
Yeah.
things because there's this constant algorithmic improvement
Yeah.
to what's
Yeah.
being done. So now for the full stack thing is the the product. Because people think, oh, super intelligence and all the other things, but like what do you do with it? And here we know in terms of like what you do with not just the large language model, it's turning it into robotaxi, turning it into Tesla bot, human bot, and scaling those things. You know, robotaxi at scale, Tesla bot at scale. And another big one is coding at scale. That those I think are um, the big holy grails of what you want. You want a labor multiplier similar to when we went to industrial revolution,
Mhm.
farmers going to combines being 100 times more efficient.
Right.
That's what we want to have happen, where it's like the technology makes us 100 times more efficient, um, 10 times more efficient on transportation, right? Have these huge multipliers of our economy, similar to industrial revolution. Industrial revolution took 100 years, but we went up from 1 trillion to $100 trillion economy, right?
Right.
That
Right.
100x move, everyone getting 30 times, 50 times richer,
Right.
is the kind of stuff that maybe we can pack into 15 years
Right.
in
Right.
20 years, something like that. So going to the full stack thing is that being able to make Tesla bots at scale with the inference chips inside,
Hmm. Hmm.
which is the AI5 chip, and making them in the tens of millions
Right.
is what no one else has.
Right.
Like NVIDIA is trying to sell those chips, like making the equivalent of an Apple Mini, you know, size of a small box or something like that, that would have that thing. But they're pretty much only selling those things to developers. Regular people are not buying those yet.
Right.
There has to be some kind of like economic business model around, I want that to save money, make money in some way. Tesla has a business model with robotaxi, and will have a business model with Tesla Bot. And then I think they will have a business model with the distributed inference, which they talked about,
Right.
spreading around. I think the main product distributed inference will be making code for companies
Hmm. Okay.
because the overall amount of lines of code of the world is about 1 trillion lines of code. They
Hmm.
have 40 million developers doing it, each one
Hmm.
doing, 10,000 to 100,000 lines. So you need to be able to validate those lines of code and then get it
Hmm.
out there. And that is a $4 trillion-ish per year business where you have like
Hmm.
1.5 trillion for the developers, 1.5 trillion for software, 1.1 whatever trillion for cloud computing. So getting code mastered, and currently no one says, oh, we can't get code. People can say, oh, we can't get super intelligence, but no one says we can't get coding mastered because we're already having um, coding tools that
Yeah.
2x, 4x,
Oh yeah.
some claim to 10x the amount of coding that we can do. But just like um, coding assistant is like driver assist,
Yeah.
way weaker than full robotaxi. So if we have full coding thing, like if I have like Colossus just pumping out code, it could pump out potentially 10 billion, 100 billion lines of code in a second,
Right.
right? So all the certainly within in an hour, it
Yeah.
could pump out all the code that the rest of the world does in an hour,
Yeah. Yeah.
versus a year, and that'd be like one AI data center. Yeah. Okay, so the full stack. So million GPU data centers, 2026. Dojo 3 next year, maybe Dojo 4 getting to NVIDIA class. Better AI 5, AI 6 chips for inference. Different kind of AI like training versus inference. Getting an AI chip design. The products, better robotaxi, robotrucks, and bots. And then factories, and then applying the bots in the factories to do
Right.
a full stack production. And then there'll be tens of millions and then up to 100 million um, cars and bots by 2030 with those lines. So
Yeah.
So that's the full stack.
Yeah, so and the full stack is, to your point, it's one thing to talk about the fact that they have a full stack. It's another thing to say why and why does it matter?
Right.
And of course, the why and why does it matter is if I am trying to compete with a robotaxi and I have to buy the car from somebody and then I have to buy the hardware, I'm sorry, the what do you call it, the cameras or any other
Yeah.
kind of that kind of hardware in order to modify it. And then I have to buy the chip in order to run it. And then I have to put that out onto a system where now I have to, rent facilities to charge it or pay for the charging at somebody else's facility and pay 12 cents a kilowatt hour or whatever, where Tesla might be 6 cents a kilowatt hour are free if they put in solar and batteries. I mean, just keep going down, down, down the entire and insurance. We've talked about that before. Tesla's already got their own insurance, so they're already dealing with reinsurers and whatnot. So they're going to be able to be super simple for them to figure out what the insurance ramifications are of robotaxis. I mean, all of it is in-house.
Right.
Well, in-house and in a sister company.
Right. And also it's each part of it is critical for everything else because if my AI data center is weaker, I lose to someone who has a better AI data center.
Right, right,
And so if my chips are worse, I'd have fewer of them,
right.
I lose. So they have control of their destiny every step of the way, and they're able to maintain a speed of development, a scale that the others can't match. And also for the money that you make from these things, there people talk about can we make money with the foundation models that everyone's going to go free. And China could decide China only makes money on hardware. We make money on chips, we make money on cars. So they're motivated to only do open source.
Yeah,
We want to stop you from making money and getting stronger on that part. So then the competition falls into who makes more and better hardware.
yeah,
If it falls to that level of who makes more energy, who makes better hardware, then China says, "Hey, we can win that.
right.
We can we're all our goal is to prevent you from getting stronger by having just open source." So there's all kinds of competitors, and also like uh, Meta Facebook, they do that too, where they're doing a defensive move
Mhm.
where they say, "I'm second or third place. I just want you not to make money on that. I want to make money on other stuff, which I can and maybe you can't." So there's a lot of motivation to make things free in that. So then you want a finished end product solution, which is even if the software is free, I made it into a robotaxi. I
Right,
made it into a Tesla bot, which
right,
has value beyond, um, and a revenue model that's far more powerful.
right, right. And then China and India, et cetera, they have the advantage of low cost labor, but that turns into a disadvantage when you're turning it into a robotaxi or a humanoid because you don't provide the same amount of benefit over a human driver or over a human laborer. Um,
So in the advanced, we have all this AI and we have robotaxi and Tesla bot in the billions, right? Then the humans aren't there for their physical labor because you're doing that with bots. What they are doing is that they are the owners and purchasers.
right.
So you want to have that economy of people buying stuff because the purpose of the production is to supply the demand.
Mhm.
So your large market matters, but then also the amount of energy you have as a country, as a nation, will determine your ranking. Because, and that's to China's advantage, that they have, as much energy as the US and Europe combined.
Right.
So that will be how many robotaxis, how many Tesla bots, how many humanoid bots can I run in my country?
Mhm.
It's only as many as I can power.
So your energy per capita, though, is what's going to matter. So right now, would the US and China be close on energy per capita?
The US has more energy per capita.
Right,
So the US has still more energy per capita. Um, China is about half. So they have four times as many people, but they have twice as much energy,
right,
but they have half per capita.
right. And to your point earlier, and we've spent how many videos talking about this, that the number one thing that the Trump administration should be concentrating on from the standpoint of a strategic advantage or even a strategic being strategic competitively is that we should be working on getting this energy number not to double in the next 7 years, but to multiple times what it is today. And that would be something that all of the data, all the Magnificent Seven could all agree on. They could all be saying, President Trump right now, we need multiple times of our current energy levels. And we also needed, I was reading a great article the other day, can't remember who or listening to a pod, and it was phenomenal. They were so on point that you don't necessarily, in fact, you probably don't want this to go over existing transmission lines. What you want to do is you want to distribute it so that you're putting it just like Tesla is right now. I'm not Tesla, XAI. Well, Tesla 2 down in Austin, they've got the batteries and the solar farm and everything right there in Austin to run that data center. They're in Memphis. They're putting in all those gas turbines right there. So you don't have
Right.
to go over transmission lines to get that done. You don't
Right.
need transformers.
Yeah.
You're putting it right into use.
It's basically a industrialization 2.0
Yeah,
in that you have no industrialization, and then you have industrialization, and then you have AI industrialization.
right,
AI industrialization would be far more energy intense, far more compute intense, and a constant, never-ending thing on
right,
that. So um, we'll probably need, 10x the energy per person in
right,
order to have, if I want to have 20 bots or five robotaxi, I'll need 10 times more power. I can only charge, one EV, from my solar and from my whatever stuff, right?
right, right.
And I and they have maybe enough to power one bot. But if I want like 10 bots
Yeah,
and I want to have four robotaxi, then and I want to have 20 servers or servers that are equivalent of 100 times my laptop or 1,000 times my laptop, I need more power to run
right,
those things,
right.
right? So the level of energy intensity we'll have will increase. The reason that that won't wreck the environment long term is that right now the climate change global warming is about 1%. Like the sun puts 300 watts per square meter roughly, and then we have a warming effect of about 3 watts, right? So if we can remove all the extra CO2 and clean up all the energy with nuclear and solar and that kind of thing, then we can have 100 times more clean energy and still only be adding that 1%,
Mm-hmm,
3
hmm
watts.
hmm
So we can go 100 times more power per person, everything's still fine, but we have to do it clean,
Right,
right?
right.
So we'll have to circle back. I don't anticipate us doing that for 10, 20 years. Like we'll start in 10 years and then in 20 years we can complete it to go to completely clean energy. And we'll want to do it just so that, hey, we don't want to overheat ourselves. We want to do all this with clean energy so we can all be 100 times richer, right? So um, we have to fix ourselves that way, and we will, because the,
Yeah.
the money motivation is, hey, we have enough room to make ourselves um, 10,000 trillion dollars per year. We just have to clean up our energy. So it's like, okay, I have to do that first, and also clean up the air and the environment.
Yeah,
So
and again, you and I've talked about this so many times. I mean, you just have to. It's the focus.
yeah,
It's the focus. If the U.S. government decided tomorrow,
yeah,
if Trump and David got together,
yeah,
they said, okay, the number one thing we need in 10 years, top of the list, is we need one whatever 15 terawatts. I don't care what the number is. I can't think about it anymore
yeah,
because too many zeros. But
yeah,
whatever the number is, we need that amount of power 10 years from now and this much 5 years from now. And you got the regulations out of the way and you made the incentives right, there's no way in the world the US couldn't do whatever they put their mind to.
Right.
100%. Just nuclear, solar, and batteries. I'm sure 100% sure they could do it.
Right. Yeah. I think we can do it, especially if we have AI and bots helping us. We'll be able to do
Yeah,
it
no
fast.
kidding.
Right. So, summarize Tesla, XAI, the first full stack, making their own chips, both kinds of chips, training and inference chips, making their data centers faster, better than anyone else, adding more power, and then making the robotaxi, robotrucks, and the Tesla bots, and probably the best AI for coding is the 10 pieces that you need. And the only other competitors that are close, might be NVIDIA with all the hardware parts, some of the software, and then not making as much, making their own data center. So to get someone competing on all fronts is not something that we're seeing yet. And there's huge advantages to being able to do it all yourself. Yeah. Okay. So great. So we'll talk next time. Please like and subscribe. Follow Randy on Patreon. Follow me on Patreon and all those other kind of things. So thank you. Talk next time.